Okay, it's time to do some programming. I'm going to start with an e-ink example, and the first thing I'm going to do is just rename it and save it as something else. So let's save this as CapSenseServo. Now I want to add some circuitry, so we're going to do a servo example. So let's look at the top design here, and the first thing I want to do is add a schematic page here, and I'm going to bring some resources from within the chip onto my schematic. Digital functions, pulse width modulation. So let's zoom in on that. And to run this pulse width modulation, we could use a clock. So we'll find that over here. We'll just drag a clock on, connect it up. It's defaulting at 1 megahertz, which is fine for me. Now the output of the pulse width modulation is going to go to a servo motor, so let's find an output pin, digital output pin, connect it up to the pulse width modulation output. Let's move this stuff over a bit. And just for the heck of it, let's bring a motor into the picture just to show schematically what's going on. And why not put a ground on the motor? For now. So let's configure this pin while we're here. Double click on it. Set it up with an external terminal so that we can connect up our motor. This isn't really necessary as we know which pin it is and we can just make a connection to it, but just so we can show that show it on the schematic. Digital output, hardware connection, correct. Output is going to be 8 milliamp source and sink. Okay. So now we have a pin we can connect to, and that shows that we've got a motor out here. We could draw the fact that it's a motor controller actually and not directly a motor, but this reminds me how it's connected outside. Let's program this pulse width modulation module. Double click on it. Now this is a servo motor, so you can see the waveform right here, which is defaulting. But we want the period to be say 60 hertz, which is 16,607 microseconds, and we want the pulse width to be about 1500 microseconds or 1.5 milliseconds, and you can see the pulse width down here is showing up as a low duty cycle. So note that this is being set with the compare 0 parameter. So we're going to want to modify this if we want to change the position of the servo. Let's apply that. So now we need to program it. Now that we've got the hardware connected, if we build it, it will bring these components into the design and bring all the software in that we need to run them. So let's do that. We build. So it's figuring out what it needs to pull into the program and into the resource group to handle the things, these components that we've added to the schematic. So it's routing and generating code, generating the APIs, which is really useful. It's doing a lot of work. I'm glad it's doing it and not me. Alright, build succeeded. And let's note over here, it has pulled in a bunch of generated source code. So it's got the e-ink stuff, and here we have the pulse width modulation. So let's just bring up the PWMC code, which is just the start code up, and here we have the h.h stuff. So if we look down here, we can see some of the things we can call to make things happen on the pulse width modulation module. So in here, we remember we have this compare 0 that we want to alter. So we can use this pulse width modulation set compare 0 to set up or to alter that variable. But we're going to alter it up here where we're looking at the slider. Shrink the library stuff and look at the screen C, which we loaded earlier. And we're just going to change it so that when we swipe, it changes the position instead of the display. We can go down to here where it says move arrow up. And we don't want to move the arrow, we want to do our thing instead. So for now I'm just going to comment this stuff out. And instead of all that, we're going to put in our functions to change the compare values. Okay, so that is incomplete. We're going to put in here a variable that says, say, servo count, and of course we have to define that servo count somewhere, declare it somewhere. I'm just going to go up here and put it in here. Now, there was another function in there called get. So we could do a get compare. Actually, let's copy it from here and put it into our program. So let's set the servo, whoops, equal to servo. So we get the servo count and then we can set it. So, but we're moving up here, so let's say if the servo count is less than 1900 microseconds, we're going to say servo count equals servo count plus 100. So if we're less than the maximum count, we will add 100 and then send it back out to the compare variable. So this should make it go in one direction. And of course we're going to want to go the other direction when the move arrow down happens. So we're going to comment this stuff out for now and add our code in instead. So we're still going to get compare, and this time we want it to go the other way. So we're going to say if it's greater than 1100, we're going to subtract 100. So this means that it will go in the other direction, 100 counts at a time. So this is about 10% of the total. It's changing it from 1 millisecond to 2 milliseconds with 100 microsecond steps. Now we also need to start the servo. So if we go to the main program here, main, and we want to do this. We want to do this start function in the main, which is here. So here where it's initializing things, we can just do the start. So now we started our pulse width modulation, and we have it going up and down based on swiping. Pretty straightforward stuff, but we're really hacking up this e-ink program. So something else we want to do is have a splash screen that displays the servo stuff instead of the menu that's there. So if we go down to screen contents, and have a look at what's there. So this is some of the menu text that shows up when you're scrolling through these menus. And down here we have bitmaps of the screen. So for example, here's the logo bitmap, the initial splash screen, and then below that we have a background image, and then we have the main menu image. That's the one I'm going to change. I'm going to just copy an image in here, and then we're done. And then I'll run the program and you can see what it looks like. I have to do a build and program it into the device. Let me see if I can find a file to copy in there. Main menu image. So I'm just going to cut all this stuff out. Oops. It's 176 lines long. And replace it with a new image, and then we just compile it or build it, generate application, and program it. And then I'll just run the program and you can see what the result was.